Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett and we talk about all things Gen Chem related on this channel. In this video, we're going to learn how to actually count the molar mass for a compound and how we're going to weave that into our mole island and ultimately do conversions from moles to molecules and molecules to moles to grams. Let's get started. So in the previous chapter, we learned how to determine the molar mass of an element. We found that the molar mass was the mass that's found on the periodic table set equal to 1 mole for that particular element. When we're dealing with the molar mass of a compound, it's the same thing, but we just have to account for the overall mass that is associated with that particular compound. And how we do that is by determining the formula mass for the entire compound. And we simply add up the individual masses for each of the elements to make the formula mass. And make sure when you're adding this that you account for how many of the atoms are present. So if it says, like in this example, H2O, that means I have to account for 2 hydrogens plus the mass of 1 oxygen. And so the formula mass would be 18.02. And so we would set that equal to 1 mole for the compound. Now, last video, in a previous video, I introduced this idea of mole island. And so we're still going to use that as we do some of our conversions. So just for us to revisit that, we have mole island here. That's the center part. Over here, we showed that we would write grams. Over here, in the previous videos, we did just atoms. Well, now we're going to expand that side of the periodic, or that side of mole island. Rather than just counting atoms, remember this side is for counting, we can also count molecules if we're dealing with a molecular compound, and we can count formula units. And remember, a formula unit is just simply the simplest whole number ratio for an ionic compound. And so just like before, we can go from atoms to moles or moles to atoms by either multiplying or dividing by Avogadro's number. And so over here, we still say AV's number is equal to 1 mole. Remember that AV's number is 6.022 times 10 to the 23rd of whatever we're counting. Okay. And then over here, we can still go from moles to grams or grams to moles. And that's going to be using the molar mass. And that's taking the atomic mass or the formula mass equal to 1 mole. And so this is going to come from the periodic table. Okay. And that represents our molar mass. And so if you're dealing with a compound, you have to add up all the masses for the elements that are shown there. Just like before, you notice I did not draw an arrow between grams and atoms or grams and molecules or grams and formula units because I cannot do that in a direct step. I have to go from grams to moles, then moles to the respective unit. Okay, so keep this in mind as we approach these next few problems. Okay, so in this case, it says, how many moles are in 50 grams of PbO2? And so this would be lead 4 oxide. We know it's an ionic compound. And so we're looking to go from grams, 50 grams of PbO2 to moles of PbO2. We ask ourselves, well, how many steps should this take? I'm starting in grams and I want to get to moles. And so for that to happen, I would have to use the molar mass. Think about that mole island. And so I know unit-wise, I would put grams of PbO2 on the bottom. I want to cancel that out. Moles of PbO2 goes on the top. And now here's where we have to calculate the molar mass of the total compound. And so I see I have 207.2 from lead plus oxygen, which is 16, but I have 2 of them. And so we have to do that first in order to write our proper molar mass. So 16 times 2 plus 207.2, and that gives me 239.2 on the bottom is to 1 mole on the top. When we plug that into our calculators, 50 divided by 239.2, and that gives us 0.209 moles of PbO2. Again, we have 3 sig figs because we started with 3 in the given amount. Okay. Good. Let's try another problem. Sorry, it's cut off a bit for you here, but I'll read it to you. So it says find the number of CO2 molecules in 10.8 grams of dry ice. And dry ice is just simply the solid form of CO2. Okay, so let's ask ourselves, how many steps should this take? Well, I'm going from 10.8 grams of dry ice, or CO2, and I want to get to molecules of CO2. So the question you should ask yourself is, can I go directly from grams to molecules in one step? And much like before on what we saw on the mole island, no, we cannot. We have to go from grams to moles, because moles is our linking unit, and then from moles to molecules. And so this is telling us this should take 2 steps. So we put 2 places for our conversion factors. We know to go from grams to moles, we need the molar mass, and that comes from the periodic table. So we would take the mass of carbon, which is 12.01, plus the mass of oxygen, which is 16, but remember, there are 2 of them. So make sure you multiply that by 2, okay? And so that gives me 16 times 2, which is 32, plus 12.01. Always make sure you take those numbers, those masses, to at least 2 places past the decimal. That gives us 44.01 as the molar mass. So there would be grams of CO2 on the bottom to moles of CO2. Always, always, always put your units in first. That'll help make converting so much easier. And so then we go from 1 mole is 44.01 grams here. And then we want to go from moles, so we put that on the bottom, to molecules of CO2, so we put that on top. And again, think back to Mole Island. We know we're going to use Avogadro's number, so it's that many when we're counting in 1 mole. We're then ready to put it in our calculators, so go ahead and do 10.8 times Avogadro's number divided by 44.01 grams. And what we end up getting is 1.48 molecules of CO2. Okay, make sure, again, multiply across the top, divide for anything that's on the bottom. Okay, next problem. We want how many formula units are in 50.0 grams of lead 4 oxide. Again, that word formula unit is just telling us we're dealing with an ionic compound. Ionic compounds cannot exist as individual molecules, but when we're approaching this problem, we're going to treat it kind of the same, because it's all in that same portion of Mole Island where we're trying to count things. And so here, our starting point is 50.0 grams of PbO2. We want formula units of PbO2. And again, we should ask ourselves, how many steps should this take? I know I'm going to have to go from grams to moles, and then moles to formula units to solve this out. Think Mole Island. We can put our units in. Should be 2 steps. If I want to get rid of the grams, I put those on the bottom first. And I'm first getting 2 moles. That's always my step. If I'm not in moles, get 2 moles first. You're going to hear me say that a lot through these videos, because that really is going to be your first step, because the mole is the linking unit to so many things. After we're in moles, we can then go from moles, put it on the bottom, to formula units. I'm just going to write F units here just for the sake of space on the top. And then we fill in the information. We know to go from grams to moles, I need the molar mass, and that's from the periodic table, adding up all those masses. We've done this one in the past, so we know that as 239.2 is for every 1 mole. Put the units in first. Don't worry, does the one go on top? Does the one go on the bottom? If you write the units down first, that'll help you figure out where you should put the one. For the second part, I know we would use Avogadro's number, and we say that in 1 mole, when I'm counting something, there's this many of that thing there. And so now we put this in the calculator, 50 grams times 6.022 e to the 23 divided by 239.2. And what we end up with is 1.26 when we round times 10 to the 23rd formula units of lead 4 oxide. Okay. It's important to make sure when you are given a problem like this, if they would have given you the name of the formula versus the actual written out molecular formula or formula in this case, empirical formula, that you first figure out what that formula is, because that's the only way you can figure out what the molar mass is of that compound. So make sure if they just give you a name, first make sure you come up with the proper formula, okay? One more problem. It says, what is the mass of 4.78 times 10 to the 24 NO2 molecules? And so again, let's ask ourselves, we're starting at 4.78 times 10 to the 24 NO2 molecules. And we want the mass. Mass means grams. So we want grams of NO2. Okay, sometimes they may not explicitly state what you're solving for, but you have to use the words as context clues to figure out what you're solving for. We know that we can't go from molecules to grams in one step. I have to go from molecules to moles, then moles to grams. Again, if you're not in moles, get to moles first. So on the bottom here, I would put molecules of NO2, and we're going to moles of NO2 as the first step. Then once I'm in my connecting unit, I can then go from moles of NO2 to grams of NO2. Think about the relationships when I'm going from molecules to moles, or atoms to moles, or formula units to moles. When I'm counting 2 moles, I'm using Avogadro's number. So that would be 1 mole is to 6.022 times 10 to the 23rd. And for the moles to grams, that's the molar mass. So we have to first calculate the molar mass. So nitrogen, which is 14.01, plus oxygen, which is 16.0, but there's 2 of them. So you got to make sure you add up those masses correctly. So we'd have 32 plus 14.01 gives us 46.01. That would go up top. 46.01 is to 1 mole. When we plug that in, we end up with 4.78 e to the 24 times 46.01 divided by 6.022 e to the 23. And that gives us a total of 365 grams of nitrogen dioxide. I hope this video helped you understand how to calculate the molar mass of these compounds and how to use this with Mole Island. Be sure to like, comment, and subscribe for more information that you would like to see from this channel. I hope you all enjoyed this video, and I'll see you guys next time. Have a great day. Bye.